just back here. So today, let me go ahead and get the right. Oh, I got my fan going on. Let me turn off the fan real quick. There you go. It's a bit hard to use with a foot, but I got it. So let's switch over to my laptop camera. So today, I want to practice soldering with, or just practice soldering and get some of my joints done. If things go well today, then I should be able to get my electronic speed controller or ESCs all soldered up, at least one of them, soldered up with these bullet connectors. Here we go, we got a female bullet connector, has this little, oh, this is one that I messed up soldering yesterday when I was just practicing a little bit. Here's the male bullet connectors. You can see has this little well. And soldering these is pretty new to me, but I at least want to give it a shot. So let's go ahead and take a look to see how this all goes. Let me make sure that my live stream, okay, it's muted. I don't think I have anything else on here that might make noise. And I have my microphone in a bit of a different spot because I am filming just off camera there. I guess you can see me on this cam. But yeah, I'm filming just off camera here, hopefully to get some B-roll while I make this project. But to start us off, I'm going to, oh actually what gauge wire is this? I think this is 18? Yep, 18 gauge copper stranded wire. I'm going to go ahead and strip, I'll strip probably 1/4 inch off, like 4 millimeters give or take. Hey, that went pretty good. I'm getting actually a lot better at stripping these things. At first it gave me a lot of trouble. Oh, let's also make sure that my title is correct here. Soldering wires. Soldering bullet connectors to SCs and brushless motors. Alright. So yeah, we're soldering these bullet connectors onto my ESCs and my brushless motors, at least soon enough. Should be fun. Let's make sure my title is correct here. Yup. Okie dokie. So where'd my wire go? So we got the wire going here. Let me flip up this camera view just to make sure I'm all in focus or focused enough. Yeah, that looks good enough. Alright, so we got this. Oh, let me get this set up. I want to make sure you guys are able to see it okay. And first thing we're going to do is we're going to go ahead and tin the wires. I'm going to go ahead and start up my soldering iron. It's just heating up real quick. Alright. I'm going to turn my iron to 350 Celsius to at least just get it started. If you hear some humming in the background, it's because I'm going to have my solder fume fan going so I don't get cancer. And I'll try speed 1, but I might have to put it up to speed 2, so I'm sorry for the volume in advance. sure my camera's in focus as well. There's a lot of juggling going on here. Alright, got this done. Alright, got this getting heated up. Where's my solder? Right now I'm using the Kester 6337 solder. It's about 3.3% rosin core solder. I'm trying to use better quality solder because I hear that helps a lot when it comes to basically just getting all these jobs done. So hopefully this all goes according to plan. Let's get this a bit closer to the project. Alright. Now let's go ahead and see if my tip is going right. I'm just making sure these fumes get all sucked up. I'm glad this is a... Oh, this is perfect. Okay, this looks great. It's already much better than it was yesterday when I was trying all this out. Okay. Now I'm going to touch my iron to my wire for a couple seconds. And then, oh, this is way better. Beautiful. And you want to heat it up just enough so that it flows through the wire okay. And that should be good. Let's go ahead and take a quick look at that. And I don't know if you should be turning on and off your soldering iron or not. I'm not quite so familiar. Yeah, this is looking pretty decent. If you guys can see that okay. But yeah. So that's looking pretty solid. And you know what? Let's just double check. Good soldering iron tip. Okay, so 350 actually might be a little warm, so I'm going to turn that down from 350. Let's try 330 and see how that goes. Where's my bullet connector? Alright, and then for the bullet connector here, get this all set up. I'm gonna get this started a little bit differently. So for the bullet connector, I guess I could do it like this. Make sure this is in focus. Alright, and then for the bullet connector here, first what we're going to do is get the connector itself heated up a bit. Swap hands for this. I'm going to get OBS pulled up. There we go. It's a bit more live. Okay. Let the iron sit in the connector for a little bit and then flow in that solder. Go about halfway. Actually, I'm going to move this connector up a tiny bit. Just make sure the solder flows the correct direction. Okay. That should be a good start. Put my iron away for a second. I'm really trying to figure out the best placement for this little fan here. You're supposed to have it about 6 inches from your little workstation here, but then my iron station's behind the fan, so I have to work on that. Okay, but I'm going to go ahead and line up the wire with this bullet connector, and I want to get it so about it. Yeah. Have this at an angle where it is gonna hold the solder properly. And then for the wire, I want it just sitting in there all snug like. That should be good. And let's go ahead and reheat this wire in the connector. Actually, let me go ahead and clean off this iron a little bit. This is my first time using this tip in particular, so that could also be why it's being a little funky on me. Might be burning off some of the factory stuff. Alright, so let it reheat for a second, and then it should be good. Let it reheat with the wire. Sit for a couple seconds, and then we should be good to keep going. Oh, I see. Okay, the wire wasn't quite seated deep enough into the bullet connector. It seemed a bit too wobbly. There's too much wibble on its wobble. Alright. And now that's looking pretty good. I'm gonna go ahead and kick up my fan to the next level. There we go, just because there's a bit much smoke. Don't like inhaling that. And, oh, I hope it looks like my vice grips are holding a bit tightly onto my wire. Oh, because I melted some of the plastic. It got a little bit too hot. Okay, okay. We're learning, we're learning. Looks like the solder may still be drying. Or is it good? Let's let that sit for a second. Alright. So I think I'm going to practice again with another wire head just to see how that goes. Where's my solder sucker? Now, I don't have a solder wick, but I do have a solder sucker. And with this, you just click it down, and then you have this little button, and it sucks it right up, and it basically just huffs it in to there. Alright, let's check this out. So here we have the joint. Okay, and with the joint here, it's kind of hard to see, but it actually seems to be a pretty solid solder job, if I do say so myself. Not too bad, it doesn't really move. Okay. And it's super shiny too. I'll let you guys see that here. Now I don't know how explicitly how full this bullet connector needs to be, but it seems like it's making a pretty good mechanical connection there inside. So for now, I'm gonna have this be my standard essentially, and given it up close to this camera. Alright, let's go ahead and try that again. That went pretty well. So where's my wire strippers? Go ahead and turn off my iron for now. Alright. And will salvage this bullet connector when the time comes, but for now I'm just gonna lop it off for the video. I'll probably be working on this in my spare time as well. Right now I'm just trying to practice my soldering technique, just to make sure if I could get consistent on it. Then I'll actually endanger the lives of my expensive parts with the ESCs and the thrusters. Alright, let's try this time with a bullet connector, or like a male bullet connector. Okay, and with the male bullet connector again, much more shallow there. And here's the head of it. Okay, this one will have to hold a little bit different, just because the anatomy of the whole thing. Alright. And before we start, let's get our wire prep, just so we could get everything banged out. 12, 14, 16, 18. And this one seems much more shallow, so I'm going to try doing like, I don't know, but much less wire to see if that helps get everything seated properly. Alright, wire strip successfully. Give that a little twist, a little Oliver twist, a little Oliver twist. Alright, and actually before I do my little bullet connector, I'm gonna, well, actually no, let's do the bullet connector first, that sounds right. Because essentially we're tinning the wire and we're tinning the bullet connector. The order doesn't necessarily matter, but for our purposes, might as well get things done as well as we can. Alright, just make sure my camera's in focus. Alright, my wire's all prepped. Getting my soldering iron ready. There we go. Okay. Alright, now we got our soldering iron tip already tinned. Now we're going to heat up the wire and feed in some solder. Okay. Now again, we're going to do the bullet connector. We're just going to heat up the connector first. This is a very shallow well, so hopefully this goes okay. I might actually need to use a finer tip. I don't know. Okay, that looks about good. So I got that bullet connector about halfway filled again. It's a bit hard because it is such a shallow connector for these male ones I got. I don't quite know what to search or how to refine that, but for now we'll see if it gives me any trouble, and then in the future we will address that. Alright. going to go back. We're going to heat back up the solder in the bullet connector. It's a bit hard. These grips aren't really holding it super well. I want to make sure I get the wire really in there. Oh, shoot. Oh, hot, 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 hot. These things are quite warm. Okay, I think that's as good as I'm going to get the wire in there. So I'm definitely learning with these male connectors especially. It's a bit extra difficult. Alright, let's see how this joint comes out. Letting it cool for a second. I'm a big fan of these helping hands. These were recommended by Adam Savage over on Tested. And I also gotta say they're a lot better than the other like little crappy alligator clip ones that you might see around. But there's a bit of a learning curve. They have so many different axes of rotation and of what's the word? Bending, or not even bending, just like they're doing the right angle, whatever that might be. But it's a bit of a learning curve to make sure these operate right. I could probably even loosen some of the joints to make it a bit more manageable. Not too sure though what I would prefer at this point. Alright, our joint might be good here. Alright, I think for the male connectors, I really need to make sure that I am taking my time to, what's the word? Strip the wires a bit less. Show you guys here. So I guess you guys can let me know in the comments how good or bad this solder job is on the male connector. Show that to the camera. Make sure it looks all pretty and nice. Alright, now that we got it all set, let's go ahead and give this a bit of a tug job. Okay. So that's pretty well in there. That's not, doesn't want to come out. It's not really bending at all. Alright. See, the question is, when do I start risking the sacrifice of my ESCs and my thrusters? I don't know, I'm feeling pretty confident. I kind of want to try it out. But I also don't want to mess up my toys. I think I'm gonna do it. Let's try it out. Let's try it out. What could go wrong? Ow, fucker. Oh, it wasn't hot. It was just very pointy. All right, one moment. You see, I really don't want to take my ESC out of this nice like plastic cover. 'Cause, you know, it's a nice Blue Robotics BESC 30R3, 2 to 6 second electronic speed controller, and they cost enough where I just don't want to rinse through them. But let's go ahead and see what happens when we try to solder them. Trial by fire, right? Ooh, I just got scissors. Oh, there we go. Found me my scissors. It hurts to cut this right now, I'm not gonna lie. It hurts quite a bit. Alright. Okay. Here we got this beautiful Blue Robotics Basic ESC. So it is pretty neat at least. Alright, now I'm actually kind of forgetting here what I want for this. Ooh, okay, hold on. Let me place this on this little anti-static thingy. And let's go to the internet. So I'm gonna go back to the main stream. I'm gonna turn off my fan. Alright. And let's double check what each of these little things are for. Blue Robotics Basic ESC. Alright, because I need to double check what each of these feed through. I forget the coloring. The coloring guidelines for these. Maybe it'll tell us here, hopefully. Technical details. By any chance, does it say what the colors mean on the wire? Because I forget, like blue, green. I want to say blue is ground and green is... No, I think green's signal. Is it blue is power and white is ground? Let's check on that. Oh, shit. Okay, that's water. Oh, for some reason I thought that was like molten solder. On my soldering iron thing here, I just knocked it and the water splashed underneath the sponge. Wait, where am I going with my mouse? Oh, here I am. Alright, so we're going to go to ChatGPT. And let's go ahead and check here for the Blue Robotics Basic ESC. Can you remind me what each of the colors correspond to regarding power, ground, and signal? Let's double check on the chip itself if it tells us anything. We are not so lucky. See, that's no fair. It tells us on the power side, but it does not tell us on the thruster side. I guess it doesn't matter because one of them, like, if you get it reversed, then it just will reverse the thrust of the thruster, or reverse the direction of the thruster. So we got red, of course, is battery positive. Black, battery negative, sure. Then we have 3 motor outputs. Oop, hold on, I got a call coming in. Hello? No? Can't you hear me? No. Oh, what's up? I can in a little bit. I'm busy for the while. meant to mute my mic. My bad. Other AD. Order does not matter for functionality. Oh. Okay. So apparently the order does not matter. Let's check here. Very important. So we got my thruster side wires are white, green, and blue. To confirm, you are saying the order doesn't right. Also, all these are bullet connectors, right? I've already fed it all the things I'm going to do here. I'm just using this to double check. See, order does not matter functionality. If it spins the wrong direction, swap any two of these wires, reverse its direction, that's it, nothing gets damaged. Are these bullet connectors? Yes. I'm using gold plated, yep. Not exposed to water. Okay. To use, and I plan to do female connectors on the power side, like towards the battery direction. The ESC side would go toward the power source. Is this generally the expected standard? Let's just double check if we are following the general standards that other people can understand if they ever are to work on this. All right. So ESC with female and thruster with male. I mean, hey, if it's a male, it's probably a thruster. Am I right, guys? Yes, 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 yes. Let's confirm. ESC side, thruster side. Yes. Yes, and yes. Okie dokie. Now, right now my ESC side has, don't even know what the is called, but it's the one that you put the little screw in. Oh, let me swap scenarios. So on my ESC side, I have these little screw terminal type looking things. And I'm going to keep that for now because I might just hook this up on the screw side to a fuse. But for now, I'm going to do the bullet connectors. Now again, am I really prepared for this? Not necessarily, but you know, eventually in life you are going to need to take risks, and that is what we're doing here today. If anything, we'll be failing forward. So these wires come pre-tinned because they are very nice over at Blue Robotics. So I'm going to go ahead and look here to get the bullet connector set up. So on this end, these are the wires that are going to be connecting to the thruster. There are 3 different wires here, and the order does not matter. We have white, green, and blue. I will be attaching, these female gold-plated bullet connectors, and this will be what I use to connect to my thruster. So let's go ahead and get these prepped. I'm going to start by tinning the female bullet connector. All right, I'm going to start by tinning the female connector. In doing so, we're going to fill it about halfway up with solder, and then we're going to introduce the wire we're connecting, and hopefully that all works out all good and proper. I just have my soldering iron heating up real quick. I'm getting my wire into position. All right. I'm just getting everything situated for camera here, so the camera picks it all up. I really wish I busted out my polarized lens for my camera, but I was being lazy. I repeat, I was being lazy. Okay, let's get my fan kicked on. Alright, I'm gonna go ahead and clean off my tip. Okay. Alright. Burnt off the old solder. Tinning it with the new solder. Okay. Let's go ahead and swap pans here. Ambidextrous for the win. Okay, and to start us off, I am just warming up the bullet connector. Okay, I got the bullet connector about half filled. And then we're gonna continue to heat it up. Okay. Alright, let's go ahead and get this wire all situated. Everything's looking pretty well, actually. I'm pretty happy with this. Okay. So looking well and good. Perfect. I'm just gonna let that joint sit for a second. attention. Let that fan run for a second just to make sure everything gets sucked out. Hey, oh, no audio. Huh? Hold on. I hope I'm not getting trolled. There we go, turning off the fan now. It's just too quiet. Oh, okay. Hey, thanks for coming in and letting me know. How is this? Is this better? What would you say? Because it's hard for me to really tell on stream. Even in recordings, it sounds way different. So I'm trying to balance it. Yeah, good. Awesome. Well, what's this? KGS soap. My mic's right in the worst spot for this, but KGS soap right here. We are just soldering our bullet connectors onto our ESC we got going on. We just got our first one done. See if we could bring this over to you to give you a look. So it's not too bad. This is the first time I'm soldering this actual ESC, so it's not the best work, but it's doing pretty well. Yeah, so the end goal of this project, I am building a autonomous underwater vehicle. Let's see if I can pull anything up for you regarding it. Not really. But yeah, it's essentially going to be an autonomous underwater vehicle where, let me get the hole. We got, this is the body of the submarine essentially. And with this, the goal is to have it be piloted autonomously. I have 2 to 3 thrusters. I haven't fully finalized the design on that. And with the thrusters, it's going to be able to do missions where it pilots itself autonomously. It'll have an onboard camera and a AI system where when it detects objects of interest, it'll take time-stamped screenshots with the camera, and then it's going to log that into a file along with pressure and temperature data, and essentially be a vehicle or vessel that will be able to do either research work or surveillance work, depending on what job I'm applying to is how I'll frame that. But it's mostly just a good chance to practice electronics and systems design as well as my programming. But yeah, so right now I'm just trying to get the power distribution set up all started. So I'm wiring all the connectors, getting the battery all set up, and making sure I implement the fuses and the arming plug. So basically I'm getting the power all set up safely so that when things do go wrong, it doesn't blow up the entire thing. Fingers crossed. It might. Warning, it might blow up. But for now, we're avoiding the explosions. Are you interested in like STEM or engineering type stuff, or what are you into? Right. Hey, honestly, me neither. I'm basically just getting started here. I'm second year for college, but in terms of my own exploring this, probably I would say effectively like 6 to 8 months worth of experience on my end with messing with this stuff and learning about it and really going deep into it. Do you know what sort of field you want to go into? Because there's mechanical, electrical, industrial, chemical. There's all sorts of different subfields of engineering or STEM related type things. Aerospace. Right now I'm applying for a lot of aerospace things. I actually had an interview with a research lab for the military not too long ago, and hopefully that goes well. I have a friend who also works at GA, General Atomics. Aerospace is probably one of my top 3 fields I may work in. For me, it goes tech, and then electronics, and then aerospace. Do you think you want to work in defense or more like commercial airplanes? Or when it comes to learning, mm, there's a general answer and a more specific answer. Do you know what aspect of aerospace engineering you want to learn more about? Is it, how to build things? Do you want to learn about just the general concepts? Because there's different levels of depth I could point you to and what works for me. See. Okay, so you want to be able to make rocket engines. I would say, as with anything, I guess I'll give you a parallel with art. So with art, they say there's different tiers to an artist. If you're just reproducing things, that's following tutorials, going step by step, or in learning the basic skills. That's one phase. And then there's also a bunch of different phases, and then eventually you'll start making your own art. And when it comes to learning skills, you want to start at the most basic stage where you're basically reproducing other people's work and learning the core concepts and foundational skills. So I would say when it comes to making rocket engines, definitely find some YouTube channels or resources you like that will give you the general theory, get you familiar with some of the terminology, as well as give you exposure to different projects. And then once you have the general idea of the type of project you want to make, then it goes down to learning the skills you may need. And for that, you want to get familiar with the rocket engine. Are you going to have to do any coding? If so, you want to figure out what is the most popular coding language. And to do this, let me go ahead and go to my laptop screen. There's, of course, ChatGPT. I love talking in chat. But then also, you could also go to somewhere like LinkedIn Jobs. I don't know if I'm logged into LinkedIn right now. I'm not. Let me see if I could do it on my other screen real quick. Because I want to show you, when you have these job listings, it actually breaks down almost all the different skills you may need. So for example here, aerospace engineer. Let's see if SpaceX has anything. All right, see, here you go. Propulsion engineer. So this is very likely along the lines of making a rocket engine. So what you do is pull up the job profile. You scroll down about the job. And then you'll see here it'll give a general insight in terms of what the job entails. And then you go down here to the responsibilities and preferred skills and experience. I would highly, highly recommend. Oh, for myself, I'm 25. I had a job previously where I had a different career, and then I pivoted back to going to school just because I wanted to become an engineer. I thought that would be really fulfilling work. So I have gone through a couple of different phases of learning different skills. And I would say especially for aerospace, you want to get really familiar with 3D modeling, such as CAD, and that'll come with time. It's probably not your step one, but definitely something you want to kind of shoehorn in as you go through your different projects. And then as you go through it, you want to be more familiar with fluid dynamics, and this is going to be a bit more based on your schoolwork. Will definitely teach you a lot of this, but computer-based modeling you could also do on your own end. First thing you should try building, I would honestly say something that just generally interests you. There's a couple different ways you could go about it. You could either focus on a problem you see, such as, I want to send a message to somebody, so you could build you could be like, oh, I could use a robot to send them the message. So there's a problem-based approach, or a skills or domain-based approach. So for you, there might be good tutorials on how to make a drone. And a very, very basic drone could teach you things such as basic circuitry, could teach you how to deal with brushless motors or motor control, as well as different control logics. And you could even implement, some AI or machine learning on top of that. So with any project, you can make it as complicated or non-complicated as you want. You can even do model rockets. I'm not sure what definitely level of the system you want to be working on, but I would say a good thing to do would be, if you want to just work on the materials and see what makes a rocket like fire, like the actual the fuel for the engine, a model rocket would probably be a good start. There's also different clubs. So for yourself, how like what grade are you in? Are you in college? Are you in high school? What level are you at yourself? Because that'll also help give you direction. Because there's robotics clubs in a lot of high schools and middle schools, as well as for colleges. There's nothing but different clubs. Freshmen in college, oh, even better. So I do know that a lot of these clubs are highly competitive, but there's also, usually a variety of different clubs available, and most colleges do have some sort of rocket club or engineering club. So I would definitely start there if you have nothing to go off of. And then from that, you could also look into locally, there's different maker spaces. But I found for myself that having my own project to work on and focus on definitely motivated me to build these skills independently. For myself, or for streaming, it's been like less than a month now, so not very long. It's very intermittent. It's basically when I have time, but I'm trying to get a lot more consistent with it. My goal is to stream at least 1 to 3 times a week, depending on my availability. And for my project here for my submarine, I have all the tools I need. So as I'm working on it, I'll be streaming that. But yeah, no, for college, it's going to be a big blend of self learning and leaning on the school's resources for engineering club and the different classes they have available. I would strongly recommend, based on talking to different advisors and professionals, school's not going to teach you all the skills you need. You have to go above and beyond just studying for your homework and start building these projects, whether it be in a group setting like in an engineering club or at home. You're not going to get any internships or anything unless you have these skills to back up. So again, definitely look at the job postings for even the internships you want or may want in the future, and that'll give you a lot of guidance on the skills to focus on. But for in terms of gaining for live streaming, it's mostly just a way to build a portfolio of work for myself. So as I'm applying for different internships or jobs, I'll have my YouTube channel as well as my Twitch streams to point to. And it's also a way to get me out of my comfort zone. And hey, if I do end up building an audience, it could even be an income source. But the main thing for me is just getting a portfolio of work. So instead of having to have my own website, I could show them that I have these projects that I've worked on that are well documented and that I'm able to talk about in depth. So it's essentially giving myself practice for future interviews. Yeah, it's streaming is a bit different because you're always having to talk. It's a lot more draining than you might think. I never thought streaming would be this, not difficult, but I guess taxing. Because if you're just watching a YouTube video or even filming a YouTube video, you could stop and start whenever you want. But streaming, you have to like keep going nonstop, and that's a bit rough. Right now, my main streaming schedule is looking like Monday and Wednesdays, either in the morning or early afternoon. And then on the weekends, at least one day on the weekends. So either Friday or Saturday. And that's usually, between 12 to 4 in that time range. And how long? Anywhere from 1 to 3 hours. If I have nothing to talk about, then, I might end early. But now that I have my project stuff really hitting its stride and being able to work on it a lot more, I'm easily going to be able to stream probably 3 to 4 hours, when I do. It's been going pretty solid on that front. But let's see if I could, walk and chew bubblegum at the same time here with soldering. Let me know if you could end up hearing this fan too loud. I have this, let's see, is there a way I could show this off? No, not really. But I have a floor fume extractor. So it could get a bit loud, but let me know if it's overwhelming here on the microphone. For aerospace, when you build rocket engines, do you want to work for a place like NASA or do you want to work for like SpaceX? Or actually, or if you're not based in the U.S., I guess for your own country's space program potentially, or you could always get a visa, especially if you have those skills. But for anything engineering related, I really think it's a skills based economy for that, where you have to be able to prove what you've learned. You can't just lie on a resume, and a lot of these companies do have very technical interviews. For a project, have you ever seen something that might interest you? Yeah. Have you made anything in the past, like as a kid or through school? Like, have you ever made, a model rocket or model airplane? Because, like, for myself, even when I was in fourth grade, see if I can reach it. Like, ever since like fourth grade, I've got exposure to this just because I was lucky enough to have a family who was a bit more STEM oriented. But, even something as simple as like with an Arduino, you can create little circuits, and I've made, blinking lights, different temperature sensors. Okay. If the projects you want to make are electronics based, I would highly recommend buying an Arduino kit. They're relatively inexpensive, they're super well documented, and you could just follow some of the basic recipes and circuits that they have already built. That way you can get familiar with the process of building a circuit. I also find it very motivating, instead of trying to do a giant project all at once, having those little bite-sized little mini skill builders really helps one build excitement as also build confidence in your ability to do those things. So I would highly recommend, if you want to do anything electronics based, get started with an Arduino, get a kit, and just follow a guide, as well as find different content creators online. The more professional, the better. But there's plenty of people who are like me, who are just starting out, who are just you're basically learning the skills with. You want to start your own space exploration program. I think that's absolutely doable. Step one would be money. You have to absolutely be able to garner enough funds to build the rockets. But if you build enough skills, you will be able to definitely, attract enough investment to at least get started. There's also people in different spaces you could do. Even if you don't jump to space right away, drones are a big source of new innovation right now. You could get in aerospace in general, and then specialize more in space once you get some more credibility and more capital, because it is a very capital intense thing. I'm surprised I'm the first one you've seen do an engineering stream, but I'm also very proud that I get to be the one that you get exposure to. I honestly am not very familiar with any streamers either who do consistent engineering stuff, at least, like this type of stuff. I know there's a couple popular coding based creators, but I'm hoping to help flush out this niche as well, because I know for myself it's sometimes a struggle to find someone who's doing similar projects or similar, like building similar skills that I may be trying to pursue. Also, a huge tip. This is something that took me a while to figure out when I was getting started with my own project here. It's absolutely going to seem very intimidating. Sorry, if you see me look down, it's because I'm trying to get my fume extractor to go a bit faster. But yeah, when you're just starting out, I strongly, strongly recommend, even if you have a grand project you want to pursue, don't get too intimidated if the project seems too much to overcome at first. You really want to learn abstraction, and what that process is basically taking the big system, which might be let's say a rocket, and breaking it down into its different subsystems. So, for example, there's going to be sensors involved, so that's an input stream, and the dealing with the input's going to be its own basket of skills and components. And then there's going to be the materials of the rocket itself. That's more on the mechanical engineering side. So you have to learn what materials you may need, and that's going to be its own set of constraints. And then you're going to have the actual motor function. So I would really recommend, once you do figure out the project you want to do, you break it down into its smaller subcomponents or subsystems, and that'll also help give you a lot more direction when it comes to building your first couple major projects. But before you even get there, you really need to start building the skills so you even know the correct terminology to work with. For your aerospace stuff, do you think you're going to want to get involved with, the coding side, or do you want to have that already be done for you? Because also nowadays there's the different AIs have the coding capabilities. So if you don't like coding, then you could even just have the AI do that for you, and you could focus on the part you do enjoy. Oh, okay. Yeah, and I also don't want to. I guess I'm doing a bad job. I'm like what would the word be? Kind of like love bombing with all the information I'm giving you. And just because I also get really excited by the idea of all the engineering stuff. But yeah, it's hard because especially when you're a freshman in college and we're a bit younger, you have nothing but possibilities ahead of you. So it's hard to choose just one direction when every option is available to you. But this is also a great time in your life just to try different things out. You could try coding, see how you enjoy it. It's super coding, especially, is super accessible. You just need a very basic computer. You can do basic coding. If you want to do electronics, there's a lot of electronics kits that are relatively inexpensive as well. So that also would be a great point of advice, is just get exposure to as much as you can, because you just don't know what you don't know at this point. There could be whole subfields that you haven't even heard of that would be your niche that you actually really want to pursue. Like for myself, I thought I wanted to be a chemical engineer, but then once I started actually learning more about engineering and working on working on different projects and different learning of different subfields, I realized that electrical is actually the niche that really appeals to me most. So part of it's just getting exposure to these things. And again, I think watching some videos on it, even though you may not directly be building a skill as you watch a video, you at least gain exposure to the idea, and it will give you more direction in terms of where you want to focus in the future. Are there any kits that could help get you started? Um, I guess again, I'd have to point you back to, like, depends on what your first project is. There's nothing but different kits out there available. It's just it really depends on what niche you want to focus in on. Like for example, I know for Arduino, like for electronics, there's a bunch of different Arduino kits. I got myself an Arduino kit, and that came with a bunch of different components. Let me actually show you that, just to kind of show you what these kits might come with and look like. This is going to be a bit more of an electronics focused example, but it still will be applicable to when you do, let's say, rockets or anything else. Typically, there's going to be a handful of different components that your kit will come with, and then beyond the components, there might be some documentation, either in the form of a physical book or in terms of a website or resources you can look at. So I'm going to go ahead and show you the kit I started with when I was in literally 4th grade. And then from there, I'll show you kind of how I've branched out and, I guess matured in my approach with all this. All right, sorry, this is moving some stuff on my computer. Let's see, my kit is over here. All right, so this is something I got literally in 4th grade when I was, I don't know, 10, 11 years old. I'll just go here. And now this is probably one of the most important things I own in terms of starting to build my skills and learn more. It's a bit jam-packed with some extra stuff, but essentially these kits will come with, the main focus, which in this case was the Arduino, which is a microprocessor or microcontroller that has a bunch of different functionality as well as its own in coding environment, and it makes things a lot really easy. It has a ton of different projects you could follow, but the kits will generally come with a whole bunch of different components. This is again for learning electronics, so you'll get things such as resistors, brushed motors, servos. So a kit will generally come with most of the components you need, and usually some extra for when you want to do other projects. And then in addition to getting the raw supplies, these kits will also have, again, documentation, which will either be how to do the project, so instructions, or how to do other projects that go beyond the kit. And for my Arduino, it came with a book, and it should be right here. And this had about 10 different projects in it. Let me see if I could give you an example of some of the projects this had. And I think this was relatively inexpensive. This was, I want to say, between 50 to 100 bucks, which for the amount of knowledge it's given me is well worth the money. From this kit, I know how to handle data streams. I know how to take input from a sensor and convert that through code into a actual system file that I could then manipulate either with Microsoft Excel or different programs through Python. It taught me about resistance, capacitors, and for the kit here, it has things such as making a motorized pinwheel where it has a fan that goes around, a crystal ball, a temperature sensor, a color mixing lamp. So you get all these different projects that not only give you a basis for your portfolio that you could then show to recruiters in future jobs, but also gives you exposure to different components and skills that you could then build on and lean into further if they interest you. For me and my project, for my submarine, I'm going to have a pressure sensor as well as a temperature sensor and a camera. So even though that kit just gave me basic exposure to, how to plug in a sensor and wire it up, with that basic exposure, I'm able to expand on that. And now I understand at a deeper level how to then tie it to my data I take from my pressure sensor and how to then manipulate some of the visual data I get. So it's a little taste, an appetizer of the skills you might want to learn. But then you then have the vocabulary and exposure to it that you can then know what to ask Google or YouTube as you try to build on those skills. What equipment would you need? Yeah, and so sorry I went heavy into the Arduino kit. It's a good all-arounder to point to, and it's a really good example of a really high-quality kit that allows you to build these skills. So in terms of equipment, yeah, so you also want to be careful unless you just have money to throw around, then be my guest. But for the kits here, unless you have just money to throw around, you want to be a bit careful to not just go all in. I have a bad habit of when I want to build a new skill, I invest too heavy up front, and then I end up not using half of it. In terms of you want to try to do the bare bones as possible. So if you are actually going to be making, let's say, your own electronic circuits, there's a couple bare bone things you're going to need that for building a rocket or drone. You're going to need a decent quality soldering iron. In terms of US dollars, that could run you anywhere from 30 to 100 bucks, or actually it's been a while since I looked. It's probably more like 50 to $120 for a decent one. This Hakko soldering iron, it's the FX-888DX. This one ran me about 100 bucks. That was last year. I think it's about $120 now. But that's an example of a generally inexpensive but really high quality soldering iron. So that's one of the basic components to connect anything with electronics. I would say a microprocessor, whether it be Arduino, ESP32, Raspberry Pi, you want to get one of these. Again, these are generally inexpensive as well. The hard part is everything by themselves isn't going to break the bank. Everything together starts to add up. So you definitely want to get one thing at a time. Probably starting with just a high quality kit will get you pretty far, and then you could figure out where you need to spend your money. But if it's a drone, that's going to be, you're going to have to practice your circuits. So a basic microcontroller, you want to get a couple breadboards. They make them in different sizes. Here's a small one, and they make longer ones as well. And most of these are usually modular, so you can just clip them together and extend them as needed. So you got your soldering iron, you got your microcontroller. What else is a basic thing you might need? Honestly, if you're working with wires, you need wire crimpers. It's really just going to be based specifically on the domain you're working with. I would say step one would be find a decent quality kit that aligns with what you want to work on. So I would also figure out what is the core skill you want to build. If it is building something like, let's see what you said. You said drones or model rockets or robots. Oh, okay. So yeah, I say for you, since all of those are electronics heavy items, even if you might not be a programmer or electrical engineer or systems engineer focusing on that space, all of those domains on the hobby and student level are going to be really heavy on the electronic side. And when you're learning these things initially, you're going to have to be a jack of all trades. So I say based on your interests and based on what skills I'm seeing as I'm applying to internships and talking to recruiters, I would say get started with a good electronics kit. Because with this, let's say you make an airplane, a basic model airplane that has an engine as well as has wings you want to control. That's going to include servos. That's going to include motors, whether it be brushed or brushless motors, and all of that's going to build on skills you get from a basic electronics kit. For example, with the again Arduino kit, just because this is what I have, this came with servos as well as brush motors, and in having the kit, I now understand what on the software side how it works on the code, as well as how electronically how those servos are controlled. Similarly for the motors, I now know how to control a motor, and with just those two skills, if I just want to make something that flies to some degree, you could probably make an airplane with just those two main skills. Maybe also if you learn how to use buttons or inputs, but with just basic components and a basic idea of how it works, you can make probably a minimum viable product that you can then, what's the word? Iterate from, and make more complicated as needed. So for you, it sounds like an electronics kit is going to be a great first step. Once you get comfortable with working on a breadboard, where's my Arduino? It's crazy that everything could be in arm's reach and still disappear. But once you get comfortable working with an Arduino, or sorry, with a microcontroller and working with electronics, especially on a breadboard, these you don't need to solder. You just plug them into this breadboard and it works. Once you get used to doing that and how to make basic circuits, then you can make it more complicated by, soldering your own connections and starting to make your own electronics and robotics. But really, for anything aerospace and drone related, it sounds like electronics is going to be the way to go. And then once you get exposure to this basic circuitry, you could then learn how to code, how to make it, how to control your circuits that you build, and then from there you could figure out what other skills you want to lean into. That's a really basic way to get started on that. Ooh. Hey, my joint ended up being pretty good. Pretty happy with that solder joint. No, of course. Do you think for your school, do they have? Oh, I'll be streaming probably for at least another hour or two. Not to toot my own horn, but I want to say I'm doing pretty good on the soldering here. So I'll probably keep going until I have my ESCs all soldered and my thrusters, and that should probably take me to the next hour or two going forward. Yeah. For your school, do they have clubs you could be a part of? Because that's also a big thing a lot of these recruiters are looking for. They want to know you're able to work in a team environment and deal with a lot of different communication styles. And it's pretty hard to build those skills outside of a club or engineering club or even a professional job if you have that. There's the hard skills and then there's the interpersonal skills. So if you can't build on those interpersonal skills, which is totally valid. I have a similar hiccup on my end. I don't have I'm going to a relatively small college right now, and there is an engineering club, but they don't really suit my needs. So right now I'm doing a lot of solo stuff. So you want to make sure you have really good exposure to the hard skills, and then maybe in your classes through projects or through collaboration, you can then point to those interpersonal skills more. So there's it's kind of about being creative in how you frame those situations, and that's all. In the next probably next years when you'll be focusing on it more, you'll learn how to handle those interview style questions. There we go. Found my connectors. Yeah. For your projects, do you think you want to make something that you control with like a remote controller, or do you want to have it be autonomous, like a drone that flies with AI or its own logic? Actually, since I'm here, I could probably. I don't know why I'm not putting chat on stream. What's a good way to do this? Hmm. Okay. A good one for a controller too is maybe not even a drone necessarily. Um, but also you could look into controlling a like little boat. Boats are relatively easy to make because you just have to have something that floats, and you just have a little wire going out of it that might go to a basic remote with 2 or 3 different buttons or controls, and that could also be a great place to start. And there's definitely different boat kits that are out there. That would also be something you could consider, because even though it's not necessarily, let's say, something flying in the sky, a lot of the skills you build as you do these projects are very transferable. Because your main issue as a freshman or someone who is just getting started in engineering is just having skills that you could then apply to different aspects of your projects and different aspects of your line of work. So you just want to build skills, do a shotgun approach. As you learn more, you could specialize as needed, but just learn everything you can. You want to be a sponge. For myself, it took me, I want to say, a couple months to even figure out what terms and how to search for what I wanted. And then once I actually started building this project, I more and more was able to realize what systems and what systems I wanted to build and what skills I needed to get there. For example, now I know how to design a power distribution system. And before that, I would have been just awestruck and unable to even move forward on that. But before you do something that's like made with AI, you want to try to make something as basic as possible and then make it more complicated. So learn how to make an engine run or make a motor run. Once you can make the motor run, maybe learn how to control the motor with a basic input, maybe 1 or 2 buttons to increase or decrease the thrust. Once you got that, maybe you could add a servo, so then you could have a servo that controls the direction of the motor, and then from there you can make it more and more complicated. You really want to try to get something as barely functional as possible initially, and then through iterative building, different iterations of your project or your skill you're building, you then will be able to make it a lot cooler. Um, oh, there you go. I was trying to find. I'm trying to figure out how to put chat on stream here easily. Maybe I have to do where I'm not logged in. Man, for this project here for the submarine, that was really intimidating. That I had to, because no one knows how to build a submarine off the top of their head. And then not only that, I had to figure out what was even needed to even start building on it. And that stopped me for several months. I was like, I didn't even know where to even start. I started learning how to code. I did everything except for actually building it. But then once I realized that you're not supposed to take the entire bite all at once, you just start small and build from there. That really helped. So I kind of leaned into having my Arduino kit. And once I had that kit and started building the skills that were outlined in that book I showed you, I was able to realize that, oh, Oh, actually, let's see. Is Python the best programming language to learn as a starter? Python is really easy to learn. It could also teach you some bad habits and some syntax, or I guess, things that are more Pythonic may not be as applicable to other languages. I originally learned with Python, and that was great just because it's super easy. The language is all super easy. The syntax is super easy to understand. But I would, uh, if it will get you started, yes, do Python. Do whatever language will get you started in learning the theory behind, different aspects of coding. You just need to get started. If you want to learn with depth and understand, the background stuff on coding and lean a bit more into that domain, I would say C++ would probably be a better place to start. That way, you're actually dealing with memory and dealing with a bit more in depth parts of it all. Sorry, I'm looking to get my chat figured out. But I would say Python is plenty good. You just want to learn why you're doing what you're doing. You don't want to just, have your eyes glaze over and just follow random instructions. You want to understand why you code the way you do, how to do different loops, for loops, if statements. You want to understand how to import different Python libraries because Python has a million different libraries. You want to learn how to handle data. So there's a lot of different skills you could even build within that. But you also need to make sure that you're not going too easy on yourself. Let's see. There's pop-out chat. Oh my gosh. It was a pain in the rear to figure out how to get chat popped out. All right. I got chat popped out. Let me add this to the stream so you guys can see yourselves talk. Window capture. Call you chat. Chat 1. There we go. Chat. Hey, I did. Oh my gosh, this is my first time I've actually been able to do that properly. I am the best at this. Okay. Put chat over here. All right. Oh, really? I can't make that smaller? Hold on, I see your question. Let me just get this back up. Can I put it over here? Chat, come back. Where'd you go? Put you over here. Do this. Okay, now this is not looking right. What's the most viewers I've ever had? I want to say 2 viewers. Let's see, alt. Here we go. Or actually, no, I think 3 would probably be the max I had. Okay, that looks pretty good. This is my first time actually integrating chat. This is an evolution for me. Wow. Oh, hey, I had 4. Hey, there you go. Welcome everybody. Yeah, I think since you've been here, keeping the chat alive, it's been fluctuating between like 2 to 3. And hey, I also want to say thank you, KGS Soap, because you are one of the OGs now. Welcome, welcome, welcome as one of the OGs of the Nick Slater channel. All right, let's get my OBS popped up. Okay, it looks like it's working properly. Docs. Okay. I wish it was smoother to figure out how to implement all these things. Streaming is definitely a bit clunky. If you see a streamer who makes it look really simple and smooth, then you could tell they have experience because, oh my gosh, a lot of this stuff is not so straightforward, sadly. I'm going to turn the solder fan back on, so I apologize for the noise. What makes you like engineering? That's a great question. Ooh, since I have the camera off, I could fix my mic too. I'll try not to get too deep on that front, but I would say the reason why I like engineering is one, I had a grandfather who was an engineer, and that was just something I really looked up to him, and I saw how much respect he got from his position as an engineer and for his intelligence, and I found that very admirable. So I also wanted to help emulate that on my end. And then also, I like engineering because it's essentially a career that is only limited by your creativity and your ingenuity. For engineering, you are able to create literally anything. It's why anything in this world gets made is because of engineering. You also are able to kind of understand how the world works. You know, it's very physics heavy, very math heavy. But through engineering, I understand, you know, why a fridge may be built the way it is. It's you kind of have to look at the world in a different way and be able to overcome these problems. So I just like how it's a very intellectually stimulating career, and it also is essentially how our world functions, and it's the backdrop of a lot of the different industries that you may be familiar with. Not the best answer. I definitely gotta work on that answer just because it is gonna come up in the future for interviews. But short answer is I had a grandfather I looked up to who was an engineer, and I like to create stuff. And I think it's pretty cool to create things that are useful and that you could actually hold in your hand or make it do something in particular. Like I'm enjoying now that I've moved from programming to more like the electronic side. Is programming is really cool because you could, you know, make numbers in your screen, do all sorts of crazy stuff. But with actual electronics, you get something you can hold in your hand, and it's easier to show to people. It's easier to explain, easier to make sense, and having that sort of tactile feedback with having a product you could point to is just a different kind of satisfaction than I've seen with other fields. You know, I come from a background in insurance, and that was, you know, challenging, and there's a lot of interpersonal skills you got to work on, but it's just not that engaging, and you can kind of your mind just kind of shuts off while you do it. So having to think for a job is definitely underrated. Also, if you're in the right field, you can also work with your hands, and that's also a bonus because it's pretty nice being able to work with your hands. And just to give context for what I'm doing right now, I forget if you were here while I explained this before, but I'm soldering bullet connectors, which are these little thin connectors. They're gold plated, and as I solder them, you have to preheat the connector first, so get it warm so the solder will flow. Once you've been warming it for a couple seconds, you then slowly feed in the solder. You want to fill these bullet connectors about halfway with the solder because they have these little wells on them. And then once you get it about halfway with the solder, you let it chill out for a second, and then that's when you're going to add the wire. But for how about you for KGS Soap? You know, you say you want to be an aerospace engineer. What interests you about it? Is it just, do you just like rockets? Do you just think they're cool? What is the appeal for you? Oh no, my connector. Oh, beans and toast. That is very toasty. Yeah. Hey, I think that's as valid of an answer as any. Whew. Note to self: if you heat up a connector to 300 degrees Celsius, it's gonna be a little bit toasty. All right, that's a lesson learned. It's like touching a hot stove, a lesson you only need to learn once, hopefully. Okay. Should be good. All right. So far, I'm batting 2 for 2. I'm doing pretty good on these connectors so far, if I do say so myself. Hopefully, I could go 3 for 3. So far, the third one is not going so hot. So hopefully, we could revive our streak here. All right, let's try this out. My iron's still on, right? Yeah. The solder was being a little weird. I don't know why. Let's go ahead and get this hot. Push in the wire. That's looking pretty good. Yeah. For this project I'm working on, right now I'm just getting everything kind of built, at least on a basic level. And then once I get that established, my goal is to eventually get this where I could deploy it into the bay or the ocean and have it so it could swim through the coral and even like see fish and monitor different ecosystems. Is going to be the official test for it. But before I get to that point, once I get everything wired up for the machine here, I'm going to get it to the point where I could, on the test bench, turn on and off the motor, be able to ramp up, be able to handle max workload. So we'll be starting off with one thruster, maxing that out, and then see if I could handle the current for 3 different thrusters. And if all that goes well, we'll try to cram it into the aluminum shell I got and chuck it in a pool and see if I lose hundreds, if not thousands of dollars. Because all of this adds up. All right, while this cools here, I'm going to check a couple things on the stream. Sweet. Yeah, the hard part about learning engineering is you can't necessarily just do the one thing you want to do. Like for me, I want to build electronics, these little things like your phone or a computer or I don't know, like a toy robot. I want to build electronics like that. But you don't just go straight to soldering or creating PCBs and circuit boards. I have to learn how to, make different circuits. In this case, it's more of a macro scale because it's just easier to work with. I have to learn coding. You have to learn all these different domains. And then once you graduate from school, get your first couple internships, you can start to specialize. But it is really a journey to kind of become a jack of all trades. It's not always the most motivating, but it is just something you gotta work through as you try to become more and more professional. Ooh, I definitely used too much solder on this. Is that an issue? I don't think so. I think it should be okay. But so far for my connectors, a PCB. Yeah, so a PCB, to the best of my knowledge, stands for a printed circuit board. Let me go back to my other screen. Actually, I could do this. There we go. Sorry, I'm just messing with my scenes here. Hey, there's me. There's this. Okay. So, a PCB is essentially what you think of when you think of a circuit board. It's a printed circuit board. It is basically how you take a big circuit and make it super small. So let me see if I could chuck this together real quick. I'm going to show you kind of the example of why PCBs are pretty cool and why working on, electronics kits and stuff like Arduinos is actually so powerful because it's all basically the same thing to some degree. So this circuit's not going to make any sense. It's not really meant to be a proper one. It's just I'm just chucking in some components here so that we have a point of reference to talk about. Because I just want to give an idea of the scale you're working with when it comes to breadboard circuits versus PCB type circuits. So bear with me for a moment here while I get this set up. Now, for me, I'm still working on the breadboard scale or the more macro scale because, I just find that it's more intuitive, it's more cost effective, and there's just a lower barrier to entry to practice those type of things. But then once I get more comfortable working on a breadboard type environment, I then will be actually starting to make my own PCB boards. And from what I can tell, at least if you're making pretty simple circuits, it's not the most intimidating thing in the world. It's just you have to get familiar with the software as with almost any skill you got. Let me swap back to my laptop camera so you can see what my hands are doing over here. So I have a couple of different components here. I'm going to explain to you what these components are, and then I'll transition that to talking about PCBs and why that's kind of the ultimate goal and ultimate skill to learn in terms of basic electronics. And to remind everybody, this circuit is not meant to work. It's just to show off a couple components. All right. So, there we go. Oh, you have to go? All right, man. Well, thanks for joining. If you enjoyed the stream, you're welcome to hit that follow button. I'm going to try to stream, 2 to 3 times a week. It's been a pleasure talking with you. If you have any questions, feel free to pop in a chat. I'll answer what I can. I'm also on my own journey. But hey, you have a wonderful day. You enjoy yourself. Thank you for stopping by. Hey, thanks for the follow. I need to get those alerts set up. Right now I'm just trying to get things to function, and then I'll make it more complicated, as with any engineering thing. All right. Oh yeah, but I guess for those who are still sticking around, for a PCB, hey, U2KG Soap, you have, God bless you. So we have, here is what's this, a light sensor. We have a resistor, and then we have a physical button. And you can see how much room these take up. These are pretty beefy. Here's an LED. These are pretty large as well. Hey, we got Neg Vorsa. We have chat still alive here. What's up? What's up? We have an LED. So these are what components look like on a breadboard scale. They're pretty beefy. They're what 2 to 5 millimeters at least in size. And you can imagine when you have components where you have dozens, if not hundreds of these on the same circuit, it tends to get pretty large, especially with all the different wires. So that's where things such as PCBs come in, these printed circuit boards. And here you'll have a whole bunch of different capacitors, resistors, computer chips. And instead of taking up, this gigantic honking thing, it's like I have this little small board. And yeah, KiCad, exactly. So PCBs are pretty cool. That's why they are so useful, and why, once you get far enough into electronics, you start to work on that scale, at least if you're making relatively small or low power things. And once I get a bit more comfortable with working with circuits and electronics, and I start to develop my own products or robotics, I'm going to be focusing more on making my own PCBs as well. Oh, I almost forgot to put the heat shrink on. Ooh, does this camera? I'm not sure if I'll be able to show the magic of heat shrink super well, but I will try for stream. I don't know if everyone in chat is familiar with should I use red or black? For these components, I'm gonna do red. But I don't know if you all in chat are familiar with these, but yeah, heat shrink is awesome because it goes from this big ol' hole to this one's 1 to 3, I believe. So it's going to go to 1/3 the size and shrink down onto these components. I actually need to remind myself because it's been a moment since I've looked into putting heat shrink on a female bullet connector. Let me double check how much to cover. No, actually no. I cover the entire thing. All right, I remember now. I cover the entire female bullet connector. I'm going to take this male bullet connector and put it in just so I can make sure I know where to stop on it. And I'm going to cover the entirety of the brass or gold bullet connector. I'm also going to do a little bit more onto the wire itself. That is to give the wire some strain relief. So then as the wire wiggles or vibrates or bends, it's less likely to snap altogether and helps protect your wire from different stress, mechanical stress and movement. Let's measure this out. It's going to be about... It's nice having the male bullet connector in there because I could feel like the bulge in the gap here. So it should be about that much heat shrink. This is, what would this be? About 2 centimeters or 20 millimeters worth. I don't have a convenient inch ruler on me, but it's about an inch, give or take. And since I'm building a underwater vehicle, a submarine essentially, I am using adhesive lined heat shrink so that when it gets heated up, it actually adheres to the different components and is a bit more watertight and a bit more resistant to corrosion. And that might be a bit more heat shrink than I need, but that should be fine for our purposes. Hey, Neg Vorsa, I don't know if you're in the mood to chat, but I see that you're here on a STEM focused stream. Are you in STEM yourself? Are you in school? Are you pursuing anything? Are you just a hobbyist? What brings you to stream? And yeah, I don't think you're going to see this for chat, but you just heat it up. You want to keep your lighter moving, and the heat shrink slowly shrinks more and more. Actually, I don't need to have this in the helping hands for this. Ooh, I wish I had a better lighter, actually. This one gets a bit sooty. Oh, you can't sleep, so you're just hopping onto a random stream. I get that. No shame in that. I didn't think this fully through because I forgot this lighter gets so sooty, and as a result, it kind of is going to mess with my soldering of my male bullet connector, and that's not very bueno. Here we go. All right. Don't need the male bullet connector because I have it already adhered, and it should be good. Oh, I don't know why this lighter throws off so much soot, but let's go ahead and get this heated up a bit more. You want to give your best impression of someone in an inner city, pretending this is a spoon. I don't know if that's a very inappropriate joke, but it's what I think of when I'm heating something where I'm moving the lighter a whole bunch. It's like a movie. Oh, you search Arduino. Hey, there you go. Let's see. I might have that in my stream tag still. Let me double check my title is correct for my stream. Let's see. Yeah, okay. But I do work on Arduinos quite a bit. Right now I'm working on a bit more of a bigger picture type project. So normally for stream, I actually have my Arduino out and I'm building different little circuits to help build skills. Like not too long ago, I built a temperature sensor with an LCD screen, and I actually have that on my GitHub and also on my VODs channel, Nick Slater VODs. That stream's not as good quality. It's I'm still trying to get the audio stuff really figured out. I found that's a big bottleneck for my stuff. Is audio is not as simple as it looks. But what do you want to? I guess I don't want to keep you up. I feel bad if I encourage you to be up past your bedtime. But what do you know? Are you looking to build anything with an Arduino? What brings you to learn more about Arduinos? All right. Ooh, how's this heat shrink? It's probably a pretty good size here. Let's get this. Lighter, 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 lighter. Yeah. My goal here is to be able to get it so I'm able to help people out. And, you know, since I'm learning here with my projects, oh, curiosity. Hey, that's fair. Nothing wrong with some curiosity going on. It's awesome because it's just such a deep well of information and possibility with an Arduino or similar microcontroller. Arduinos are especially nice just because there's so much documentation where you could basically build just about any basic sort of project you may want. And there's probably an Arduino project with the exact same scope that you're looking for, which is really nice because it's a really well documented community. I recently bought a Jetson Orin Nano, which is an NVIDIA based microcontroller, and it's just a lot less easy to find high quality resources for that product. So it's really, really nice to have an Arduino to at least use to prototype, and then I could try to translate that to the Jetson stuff. Okay, I'm realizing an issue here with my heat shrink. It's really like going back the wrong direction on my terminals. Huh. I don't know if that's going to be a major deal. I could always address it with more heat shrink, but for now, I guess I'll leave it as is and hope it doesn't cause a big issue in the near future. At Mega STM32. Ooh, what's a CH582? CH582. I haven't gone too deep down the microcontroller rabbit hole. This is interesting off AliExpress. So it looks like it has some basic I/O. It has USB-A. Is that USB-C? Some in-out ports, outputs. 5 volt. Okay, so it's a 5 volt microcontroller. This is pretty cool. It definitely sounds like you're a bit further along in your journey than I am, but that is pretty cool. I haven't really focused too much on the control logic part of my build quite yet. I'm kind of just getting finalized on the power distribution stuff. But that's going to be my next step is hooking up all my microcontrollers and my kind of data processing stuff. And then once I do that, I'll be able to kind of explore that world a bit more. I just want to get something that runs, and then I'll learn how to control it. It's kind of my goal. Not really. Hey, fair enough. I guess also it's hard for these type of things, with like STEM related stuff, because there's so many different starting points as well, where if you're going down a new path, that someone may have already been down that path for quite a while, but you yourself may have exposure to different paths they may not be familiar with. So I think that's also fun with different STEM channels I've found is, even though some of the concepts they may be exploring, they may be a lot more in depth with, there's also some things you may be more familiar with that it might be new to them. So I always enjoy the journey of discovery or even rediscovery in that capacity. All right. Ooh. Okay, I'll fix this with a knife. I'm learning. I guess it's bad to practice heat shrink stuff with adhesive lined because it's a lot less forgiving. But there's definitely a balance to be struck when it comes to having your wire or your headers fully covered with it, or having them a little not covered enough, because you can see here that there's a bit of a turtleneck situation going on. You have your trim terminals that are a bit, there's a bit of the tip out there, and then there's also the extra sleeved ones. So I'm going to have to clean that up with a knife once it cools down a little bit. That's a good lesson to be learned. But I'm actually feeling pretty happy about my soldering job. When it comes to powering it I don't think I'll do that this weekend. Well, maybe next week is when I'll actually power it. But when it comes to powering it, I'm going to have to be very mindful of all these new solder joints I've just soldered on here, because if they get too hot, they will melt or burst in flames, and the things I'll be connecting them all to are pretty expensive. So I will have to contain the damage. I'll be doing that with my MIDI inline fuses. So I'll be utilizing these inline fuses. These are pretty sweet because, one, it helps with wire management because this kind of goes the same direction. Still require more time to shrink. Oh. You're saying it has more time to go with the heaters? So should I put more heat on it with the lighter, is what you're saying? Yeah. I probably should have had some more sacrificial wire, because I haven't really played much with the adhesive heat shrink. That's definitely something I'm a lot less familiar with. And it's one of the components that I haven't had much exposure to. But let's see if we add more fire. Luckily, everything I'm going to be putting the lighter on is either protected by the heat shrink, or you didn't see it well. Yeah, also, the heat shrink I could be starting with might be a little bit large in the first place. That's also part of the situation I'm running into, where the local electronics shop by my house, or even in my city, the entire city is kind of missing good electronics warehouse. They didn't have much options in terms of quality heat shrink. Oh, actually, that's a pretty good shout. You are correct. I'm still gonna go a little bit further on it. Gosh, I need to get a better lighter. Note to self: this lighter is way too dirty. Anyways, it's the tip is getting a bit closer to the front, and then also the seals by the wire. Like, for example, this guy can shrink a lot more, so that's good to know. If I was a smarter man, I would have learned these lessons before I connected it to my expensive ESC, or I don't know if these are that expensive, but my electronic speed controller. But this is at least a lesson to be learned now, if I didn't have the wisdom to learn it before. Let's see if we can get the turtleneck to kind of no longer be an issue. I'm also definitely overusing the helping hands here. It's just nice when there's a hot thing not to have to worry about the hot thing hurting you. Okay, that should be good. Oh shit. Is this getting hot enough to mess with the solder? Oh fuck. Not necessarily. I probably should be a bit careful about how I heat it, but it's not getting that crazy hot to really melt the solder too much. Plus, a lot of the flux has burned off, so it's not going to be that willing to give up its shape anyways. So this is going to be my first major ESC that I have soldered. And then I will be, I guess I'll do my next one next. Or should I do a thruster? You know what? Let's practice soldering the 10 gauge wire. That would actually be pretty solid to do. Because I tried to do the 10 gauge wire the other day and it did not end well at all. Like even close to going well. It was a bit of a disaster. See, I had a very humbling experience the other day with my solder, or my soldering iron, is because I had it in Fahrenheit, and I usually have it in Celsius, and I don't even know how this happened, but I ended up having, I thought it was going to be 350 degrees Celsius, but it was actually 350 degrees Fahrenheit, which is about half the level of temperature I needed to have for my solder. I was like, oh, this is really weird. I don't know why it's not working. I was like, it normally works just fine. And it was just hot enough to get the solder melted, but not hot enough to do it well. And when I try to do the 10 gauge wire, which is much thicker than this 18 gauge wire. So this is the 10 gauge wire, and you see it's pretty thick. It's how is this? With its insulation, it's about 5 millimeters, so pretty decently large compared to the 18 gauge wire. Ignore the connector, and the 18 gauge wire is about a third of the size. So the 18 gauge wire is working just fine, but the 10 gauge wire was not working at all. It was getting chunky. I was getting cold joints, and that did not end so hot there. So only after, at the end of the day, I was messing with my soldering iron, and I realized, oh shoot, I was in Fahrenheit on accident. So that was no bueno. We did not enjoy that. Ooh. I haven't really thought too deeply of how I'm going to store my soldered ESCs. I probably should have done that before I soldered everything to them. But hey, hindsight is 2020. All right, I'll put this in the deal with later pile. And now let's strip our 10 gauge wire and see if we can't figure out how to solder on a XT90S connector. Where is... Oh, I actually have surprise visitors. I gotta go. But if anybody here wants to follow, I'll be streaming again Monday in the morning. My name is Nick Slater. I have a YouTube channel. Check out my LinkedIn as well as my GitHub. And I'll be streaming one day either Friday or Saturday. And then typically Monday or Wednesday mornings or early afternoon. And my goal is to stream 2 to 3 times a week. Thank you very much, and be sure to hit the follow button.